Isosceles triangle theorem. Isosceles triangles. Definition. An isosceles triangle is a triangle with at least two congruent sides. An equilateral triangle is a triangle with three congruent sides. In an isosceles triangle, the base is the side that is not necessarily congruent to the other two sides, called legs. An equilateral triangle is a special case of an isosceles triangle. The vertex angle is opposite the base and is the included angle between the legs, so right here. The base angles are the angles opposite the legs and are included by a leg and the base. So these here are the base angles. Isosceles Triangle Theorem, Book 1, Proposition 5. In isosceles triangles, the angles at the base are equal to one another, and if the equal straight lines be produced further, the angles under the base will equal one another. The modern version of this idea is called the Isosceles Triangle Theorem, sometimes called the base angle theorem. The theorem states the base angles of an isosceles triangle are congruent. So given that this line segment AB is congruent to this line segment AC, then angles B and C are congruent due to the isosceles triangle theorem. Here's a proof of the isosceles triangle theorem. Given that triangle ABC is isosceles with AC congruent to BC, we're going to click here to reveal a construction. So look at that. Step 2 would be locate M, the midpoint, between A and B so that AM equals MB. Alright, so we drew M here because that's the definition of a midpoint. So now we know that this little segment here is congruent to this little segment here, and we're going to draw CM. Alright, and we drew the line through C and M because through any 2 points you can draw a line. We know that CM is congruent to CM because of the reflexive property of congruence. Alright, now we know that these two triangles here are congruent because of the SSS postulate, because we have these two sides congruent to each other, we have these two sides congruent to each other, and we have this shared side congruent with itself. So yeah, these two triangles here are congruent. Alright, and because these two triangles are congruent to one another, we know that angle A is congruent to angle B because corresponding parts of congruent triangles are congruent. CBCTC. Alternate proof of the isosceles triangle theorem. So given that this triangle is isosceles with AC being congruent to BC, we want to prove that angle A is congruent to angle B. So we begin with our given information, and we see that angle C is congruent to angle C because of the reflexive property of congruence. Therefore, triangle ABC is congruent to triangle BAC. See, there's two triangles here in different directions. Because of the side angle side postulate, we know that they are congruent to each other. Therefore, A and B are congruent because CPCTC.